Google just deployed a new AI agent internally that can write code on its own without constant human input. Meta is building systems that can predict how the human brain responds to content in real time. A new self-evolving AI agent is starting to fix one of the biggest problems in automation. And now, companies are building hardware specifically designed for AI that doesn't just assist, it works on its own. Let's start with Google, because this one is already happening quietly behind the scenes, and most people don't realize how big this shift actually is. What Google is working on right now is something called an AI agent. But this isn't the kind of AI most people are used to. This isn't just a chatbot. It's not something that waits for you to type a question and then gives you an answer. This is a system that can actually take action. The difference here is huge. Traditional AI responds. This new AI acts. And that one change is enough to completely shift how work gets done. The internal system, often referred to as agent-style AI, is designed to handle real workflows from start to finish. That means instead of just helping with coding, it can actually write code, test it, debug it, fix errors, and improve the output over multiple iterations, all without needing constant human direction. Think about that for a second. A task that used to require a developer to sit there, review every line, test everything manually, and fix problems one by one, can now be handled by a system that keeps working until the job is done. And that's where things start to feel very different. Because for a long time, AI has been positioned as a tool. Something that makes you faster. Something that makes your work easier. But still something that depends on you. Now that dependency is starting to disappear. These systems are being designed to take a goal and figure out how to complete it. They don't just respond. They plan, execute, adjust, and finish tasks. And once AI reaches that level, it stops being just a tool. It becomes something closer to a worker. And that's where the tension starts. Because when AI moves from assisting to executing, the role of the human begins to shrink. At first, companies use these systems to increase productivity. One engineer can now do the work of 2, then 3, then 5. But eventually, the question becomes unavoidable. If one person with AI can do the work of 5 people, how many people does the company actually need? And that's not a theoretical question anymore. That's a business decision. And businesses tend to move toward efficiency, which means once these systems become reliable enough, adoption won't be slow. It will accelerate. And right now, this is happening quietly. These systems are not fully public yet. They are being tested internally, refined, improved, and controlled. But once they reach a certain level of stability, they won't stay hidden. They will become products, they will become tools, and eventually, they will become standard. And that's when the real shift begins. Because once something becomes standard, it spreads fast. Now from there, let's move to Meta, because what they are building goes in a completely different direction. But it might be just as important, if not more. Meta is working on a system that tries to predict how the human brain responds to content. Not just whether you like something, not just whether you click on something, but how your brain actually reacts to it. And that's a completely different level of understanding. This system combines different types of AI models, language, video, and audio, into one unified system that can process information across time. So instead of analyzing a single image or a piece of text, it looks at sequences. It watches, listens, and reads, then tries to map that to real brain activity. And that's where things start to get interesting. Because if a system can predict how people respond, it can start optimizing content in ways we haven't seen before. Not just what gets attention, but what holds attention, what creates emotion, what keeps people engaged longer. And that has massive implications. Because now you're not just dealing with AI that generates content. You're dealing with AI that understands how humans experience content. And once that happens, everything changes. Marketing becomes more precise. Entertainment becomes more addictive. Education becomes more adaptive. social media becomes more optimized. Because if AI can predict human response, it can adjust content to maximize that response. And that's where things start to feel a little uncomfortable. Because now the question isn't just what AI can create, it's what AI can influence, and how far that influence can go. Because if a system understands what keeps you engaged, what captures your attention, and what triggers your reactions, it can shape your experience. And that's a level of control that goes beyond simple content generation. It becomes something much more powerful. And that's why this development matters, not just for technology, but for how people interact with information itself. Now from there, let's move to something that might actually solve one of the biggest limitations of AI right now. Execution. Because right now, a lot of AI systems sound impressive in demos. They can explain things well. They can generate ideas. They can simulate intelligence. But when it comes to actually completing tasks from start to finish, they often fail. They lose track. They restart. They forget what you asked. They break when something changes. And that's a major problem. Because real work is not clean. It's not linear. It changes constantly. Requirements shift. Tasks evolve. Unexpected issues come up. And most AI systems are not built to handle that level of complexity. But this new type of agent is trying to fix that. Instead of treating every change as a new request, it maintains the entire task. It understands continuity. It can pause, adjust, reorganize, and continue without resetting everything. And that might sound simple, but it's actually a huge breakthrough. Because that's what real workers do. They don't restart every time something changes. They adapt. They adjust. They keep going. And that's what this system is designed to do. It uses multiple layers of memory. One layer for stable identity, who it is and how it behaves. One for long-term context, what has happened over time. And one for the current task, what it is doing right now. And that allows it to operate across longer time frames without losing track. But the most important part is this. It can improve itself. When it fails, it doesn't just stop. It analyzes what went wrong. It identifies the cause. It adjusts its strategy. And it tries again. And over time, that creates a loop. Execution, failure, learning, improvement. And that's a very powerful cycle. Because now AI is not just getting better because engineers update it. It's getting better because it learns from experience. And that's a completely different level of capability. Because once a system can improve itself through use, it starts to evolve. And that's when things start to accelerate. Because improvement is no longer limited to updates. It becomes continuous. Now from there, let's shift to something that might not seem as exciting at first, but is actually critical to everything we've talked about. Hardware. Because none of these systems exist without the infrastructure behind them. And companies are starting to realize that. They are not just building better AI models. They are building hardware specifically designed for AI systems. And this is important because AI agents behave differently from traditional models. They don't just generate one answer. They perform sequences of actions. They run workflows. They operate continuously. And that requires a different type of computing, especially when it comes to inference, which is the stage where AI is actually doing the work, not training, not learning, but executing tasks in real time. And that's where CPUs become important. Because CPUs are designed for sequential processing, step-by-step execution, which is exactly how AI agents operate. So companies are starting to design chips optimized for this. Chips that can handle multi-step reasoning, task execution, and continuous workflows more efficiently. And this represents a shift. Because for a long time, the focus has been on GPUs, training bigger models, scaling compute. But now, the focus is expanding, from training to execution, from models to systems, from tools to workers. And that's where everything connects. Because once you combine AI agents that can execute tasks, systems that understand human behavior, models that can improve themselves, and hardware built to support all of it, You no longer have just tools. You have a new type of system. One that can operate with increasing independence. And that's where things start to change. Because when systems can handle full workflows, the role of humans begins to shift. Not disappear instantly, but evolve. Some roles shrink, some roles change, some roles disappear, and new roles begin to appear. But the transition is not always smooth, because technology moves fast, and people don't always adapt at the same speed, and that creates uncertainty. Because now the question is not just what AI can do, it's how quickly it will be adopted. And once adoption begins, it accelerates. Because companies compete. And when one company becomes more efficient, others follow. And that's how industries transform. Not slowly, but in waves. And right now, we are at the beginning of one of those waves. A shift from AI as a tool, to AI as a system, to AI as something that can actually perform work. And that is why this moment matters. Because this is not just about what AI can do today. It's about what it will be able to do tomorrow, and how that changes everything built around it. From jobs, to companies, to entire industries. And the real question is not whether this shift will happen. It's how fast it will happen, and who will be ready when it does.